Hello and welcome to another edition of Mr. Walker's Chemistry. Today we're going to be looking at acid nomenclature, or in other words, how do we name acids? So before we could really get into how do we name them, I think it's a good idea to cover first, how do you identify an acid? How do you know that something is an acid? So, what is an acid? Well, there are several definitions. If you go to the internet and you search for what is an acid, you're going to get a lot of different definitions. You're going to get things like it donates a proton, or it accepts a hydroxide anion, all sorts of different things. For now, in terms of nomenclature, it's just something that starts with hydrogen, starts with the H. All right. So here are several examples. HCl, H2SO4, HNO3, H3PO4. Those are all acids because you can see they clearly begin with an H. Now it can be 1, 2, 3, all sorts of different numbers of hydrogens. Okay, so knowing what they are, let's go ahead and try and name them. Now it's really easy. Acids are not difficult. You just have some rules to memorize. And then it's just like with any nomenclature, it's about practicing and it's about correctly identifying them. So take your time with nomenclature. Anytime you're asked to name something, you're never in a rush. Just make sure you break down and follow those rules, just like we did for ionic and covalent nomenclature. All right. So the name of the acid comes from the anion. Remember, this is the negative, all right, the negative portion of our uh, molecule or compound. All right. So I've got some examples here. These are the examples from the other side: HCl, H2SO4. All right. Which one's the anions? All right. So you have to think back. Think back to ionic bonding. Think of these like ionic bonds. All right, and really they are. Now it could be, just cation anion like in HCl, or it could be cation and polyatomic ion, okay, SO4, NO2, NO3, sorry, and PO4 are all your polyatomics. So remember, you'll need that list in front of you of polyatomic ions in order to be able to name many of these. All right. So the anions, right? Okay, so the hydrogen in all of these is the cation, which means the anion is the Cl, the SO4, the NO3, and the PO4. All right. And when you do ionics, it's always cation, anion. So it's whatever the second half or second portion of the molecule is. All right. So it's really simple. Here's your first rule. All right. If the anion ends in an IDE, okay, then the prefix of the acid, okay, the prefix of the acid becomes hydro, and the suffix changes to IC. Okay, so for our example here, this is HCl, which if we were to name it as an ionic compound, we would name it hydrogen chloride, right? Cation, and then the anion, you change the ending to IDE. Okay, so this would be called hydrogen chloride if it were purely ionic. However, because it begins with H, we know that it's an acid. So we're going to change it according to this rule. So first thing, on the chloride, we change it to an IC. So instead of IDE, it's just IC. And then you just do hydro. It's a way to shorten it. So you kind of just shorten this down to hydrochloric acid. Okay. Another one here, HBr, hydrobromic acid. All right. We call these binary acids because they're only two atoms. Okay, binary, two atoms. Really simple. So just that's your first rule. Here are some examples. Make up your own. Okay, write down HI, name it. Write down HF, name it. Okay, keep doing stuff. So just basically hydrogen and any of your halogens is going to work just fine. Okay. All right, so some more rules. Other acids will basically you name them, but without the hydro. Um, and this is because these are basically the ones that have your polyatomics. If you have a polyatomic ion in your acid, then you don't include hydro. There's no reason for it. Um, so here are some other examples. So we have HNO3. Okay, so the anion here is NO3, which we know is nitrate. So let me write some stuff down here. Okay, so this NO3 right here is nitrate, and we get that from your polyatomic ion list. Okay, so that's nitrate. So you can see it ends in ATE. All right, so we're going to get rid of that. We're going to change it to an IC. Okay, so now it's nitric, and that's the answer, nitric acid. All right, really, really simple. Just got to keep the rules straight. So you guys can look up this one and see, you know, what it is. But you can see we changed the ending to IC, so this must be something that ends in ATE. All right, so let's erase that. Okay, so now we've got this one, okay, PO3 instead of PO4, which means that it's one less oxygen. So if you're remembering your rules from your polyatomics, then that means that it goes from an ATE to an ITE. So this PO3 is phosphite. All right. Um, so phosphite, again, polyatomic ion list, just look at it. So because it ends in ITE, all right, we're going to cross that out and change it to OUS. Okay, so it's phosphorus acid. Phosphorus acid and phosphoric acid are often used in sodas. So if you have a dark colored soda like Coke or Dr. Pepper or Mr. Pibb, something like that, usually it contains phosphoric acid. So you can always, you're sitting there taking your toast and you've got a can of soda in front of you. Just flip it around. It'll help you remember some of the stuff. Now, if you have a light colored soda or a clear soda like Sprite, usually it contains citric acid. So citric, okay? So here's one that you can practice with. Citric, okay? If it's citric, okay, then I've got the IC ending. So IC, I could cross that out and change it back to ATE. So citrate is the polyatomic ion from which citric acid is made, and we're just attaching hydrogens to it. So let's go ahead and go over to the next slide here. Now this might be helpful for you. This is taken out of your textbook, I'm pretty sure, or something like it. And it is more or less just a flow chart. It's a decision chart. It's, do you have it or not? Okay, so let's work through this. I'll do an example on the side over here while you guys follow along. So we have a basic chemical formula of QXRY. So let's do a couple of examples. So QXRY, where Q is the first element with a number X, R is whatever comes after Q with a Y. So let's do I'll do one over here that is an acid and one this will be the non-acid, okay? Non-acid, and this will be the acid. And let's follow through the flowchart here. Acid. Let's do let's just do H. Let's do H2 SO4. All right, let's just do H2SO4. Really simple. All right. And then the non-acid, let's do iron iron oxide. Okay. All right. So let's go through here. Okay. First, this is a non-acid because it does not start with an H. This is an acid because it starts with an H. So as we follow the flowchart, okay, so the Q is the Fe in this example. The X is the 2, the R is the O, and the Y is the 3. On this side, the Q is the H, the X is the 2, the R is the SO, 4 actually, and then we could put that in parentheses and put 1, so the y would be a 1. All right, so we go down here and it says, okay, is Q and H? So over here, okay, so for question, let me just say like this is question 1, okay, so for question 1 over here, and for question 1 over here. So is Q and H over here? No, okay. So for example 1, we go this way. Over here, okay, Q is, so that's a yes, so we go that way. And so it says compound is an acid. So now you need to go and use the rules of this video to name it. All right, so you have to know those 3 rules, which were if it is a binary acid, meaning it's just 2 elements, change the ending from IDE to IC and put the prefix hydro. Hydrochloric, hydrobromic, hydrofluoric. Okay. If it is if it it is not binary, meaning it has more than 2 elements, like this one and this one, then you need to follow, does the anion end in ATE, or does it end in ITE, and change the endings accordingly. Okay? All right, so this one is done. That's it. That was simple. Now we need to go through the rest of your rules. So iron and oxygen, hopefully you know it's ionic, but let's keep following through here. So is it greater than 2 elements? Iron, oxygen. So that's question number 2. And again, it's a no. Okay, so we're going to go this way. Okay. Is Q a metal? Yes, it is. It's iron. Okay, so number 3 is a yes. All right, so we go this way. Now Q, is it a group A metal? And so you remember, hopefully you remember on the top of a periodic table. So let's draw a periodic table. Sorry, it's a rough sketch. Your group A's, so you have like Roman numeral 1A, and then 2A, and then it jumps over here and it goes 3A, and so on. Okay, all your A's are the ones that are kind of up top. Well, if you go down here, it says, it's just like 1B all the way over to 10B or something, 8B I think actually, so 8B. All right, these are your B's. So these are your B's, and everything up here, those are your A's. Okay, so is it a group A? Well, we look and we see it's iron. Iron is not a group A. It is down in the transition metals. Basically, it's saying, is it a transition metal or isn't it a transition metal? So that's kind of what we go with right now. So it is a group B, meaning it's a transition metal. So it is not a group A, so we go no. And so we go down here and it says, name the ions, and then use a Roman numeral with the cation. What I've taught you all along, okay? So just follow those rules and you're fine. This is a flow chart for people who maybe are having a little bit more trouble. So if we were to name this one, the acid would be a sulfuric acid. Sulfuric acid, all right. And this one, okay, iron oxide, but what's our Roman numeral going to be? So we name the cation, so it's iron, and we know it'll be oxide, but let's put in some Roman numerals. So this has a -2, which means that this is going to be -6, which means this has to be +6 to cancel it. 6 divided by 2 is 3. So we have Roman numeral 3 here. Okay? So that's it for nomenclature. That completely wraps up all nomenclature and different types of bonding. Later on, you guys will be looking more at acids in general and seeing what are acids, what can they do, what's the true definition of them, and why do they have that definition. Okay, so let me clear everything off here. I hope that you learned something here and that this was helpful. Please rewatch, review if you need to for the acids, and again, make up your own. Take any non-metal on the periodic table, any non-metal, put some hydrogens in front of it, and name it. Okay, if it's got hydrogens in front, it's an acid. So technically H2O is an acid, okay? Uh, and you can name it as an acid. So, you know, go for it. Do some different things, see what you can come up with. All right? So I'll see you next time.